3, 2, 1, let's go! Hi everybody and welcome to another exciting edition of Boring JavaScript. I'm your host, the Virtuoid, aka Mike Smith, and today we're going to be talking about the parseFloat method. Now, just like its cousin, the parseInt method, its job is to take a string and attempt to parse it into a floating point number. And that's it. Real simple to use. Want to see how it works? Let's get started. So as I mentioned before, parseFloat will take a string and attempt to parse it out as a floating point number. So of course, there's two pieces to the parseFloat. First of all, you need the actual command itself, or the function itself, in this case, parseFloat, and it takes one argument, a string, so the second part you need is an actual string to parse out. And as you can tell here in line number 1, I've got a string 1234.45, and so I will attempt to parse that out. So what I should expect to happen here is that JavaScript will go through and say, okay, I can interpret this as 1234.45, so I'm going to assign that number to the variable number. And when console.log prints out here, you'll find out that the number will print out to be 1234.45, and the type should equal number. So it doesn't actually mutate the original string, it will interpret the string and return that into the new variable. But does it have to be strings? No, actually it could be absolutely anything. It just works best on strings, as we'll see here a little bit later on. So I've just, for fun, passed it a number, 9876.54. So what I should expect here is that number from number variable should also be 9876.54. And down here, when I do the console.log, it should be 9876.54 for the printout, and for the type, it should also be number. So this will show you that it will actually parse out not only strings, but also numbers. Want to see how it works? Sure you do. Let's flip over to Node and type in node parseFloat. And yep, there we go. Type equals number from 1234.55. Remember, that was our string. And this is our number, 9876.54, which is also type equals number. So that shows you that parseFloat will take any string and attempt to parse it as a float. Now, earlier I said it could take absolutely any argument. It doesn't necessarily have to be a string. Strings work the best because obviously strings can represent numbers. But what about all those other little data types? What about nulls? What about undefineds? What if you had your string representing, let's say, a hexadecimal number, or maybe a scientific notation number or something like that? Well, now let's take a look at some of the different options or different variables you can pass to parseFloat to see what it does with it. That's next. So what about other data types or weirdly formatted strings? Well, let's take a look at a few of them here. I've got a number of strings that we're going to take a look at. I first got a base 16 representation. I've got a scientific representation here. I've got a string that has no numbers whatsoever. I have a string that has numbers at the very beginning. I have a big int number. That's the letter N at the very end is a representation of big int. And of course I have a Boolean, a not a number, a null, an undefined, and an object there. So instead of explaining to you exactly what's going to happen here, let's just go ahead and run the program and then go back and explain what happened, why things happen the way they happen. So let's flip over to Node. Let's type in node other. And there we go. So what has happened here? All right, first of all, let's take a look at it. Base 16 came out to be 0. So let's flip back over to our code. Let's take a look at base 16. Well, it's not really 0. It's a hexadecimal notation of 1AE0. So why just 0? Well, the thing is that parseInt will take your string and start at the very beginning and start parsing it out one after another until it finds an invalid character. Once it finds an invalid character, it stops the parsing and will return to you what is already there. So with base 16 here, it got the first number, the first character, which is a 0. That's a valid character, so now 0 is the value of your return. Then it got to the letter X. The letter X basically came in and said, nope, nope, that is not a legal number for a floating point number, or for floating point number. So there are not a legal character, excuse me, for a floating point number. Therefore, we're stopping the whole process and returning you the 0. So that's one of the things to remember with parseFloat. And parseInt was like this too, if you remember my video from a number of weeks back. But parseFloat will start with the number. We'll start with the string at the very beginning, and we'll continue to parse it out until it finds an invalid character. Once it finds that, it kicks it on out. So that's the reason that, if we go back to Node, that's the reason that base 0 base 16, excuse me, came out to be 0 because X is an invalid character. All right, well, what about scientific notation? 6, 1, 2, 3, 4, 0, 0, 0. What happened there? Well, let's flick back over to our code. And the scientific notation is 6.134 e to the power of e to 7. This actually worked. Now, e is an invalid character, so technically we should have returned 6.1234, but scientific notation is parsable by a parseFloat. So that's the reason we did not end up with 6.1234, but instead ended up with 61234,000. So that gave us our 7 digits at the very end here. Right there. There's our 7 digits. So although base 16 didn't work, scientific notation does work, and it will be parsed successfully by parseFloat. So very important point to remember. Let's take a look at a couple of those strings there. Cat returned, let's flip back over to Node. Cat returned NaN, and bad string 2 returned 1.2. Let's take a look at both of those at the same time here. Now, the bad string number 1 had the word cat in there. Again, the very first time that it found the character that was invalid was the very first character, so no number had been parsed yet, so it returned a not a number. And that's the reason it returned not a number, is that there was absolutely nothing within the string there at the very beginning that had a legal character. However, this one did work, came out to be 1.2, because again, 1 and a period and a 2 are legal characters within a floating point number, but cat is not. So it stopped at the letter C and returned that. So bad string number 1 came out to be not a number, and bad string number 2 came out to be 1.2, as you can tell here back on our node. Now the big number itself, I'll tell you this from here. We don't have to go back to the code here because we've got the before and after. The before was a big, giant, long string that had the letter N at the very end. The after was a big, long, giant string, but notice that we didn't have the 8, 9, and 0. That's because the floating point number reached its maximum limit at that point and couldn't interpret the 8, 9, and 0 at the very end. So the number was too big, so basically just cut it off at that particular point. So this is an example here. If you're trying to transport big numbers and you know you got a big number or a big int coming in, you need to use big ints and not parseFloat, because then at that point things are going to kind of go wacky on you. And then finally the last 5 of them here, let's go ahead and we can go ahead and talk about them. As you can tell here, a boolean, a not a null, a null, not a number, excuse me, a null, an undefined, and an object will all return not a number. So each one of those do not get parsed out correctly. Why? Because those numbers or those particular characters are not legal characters within the parseFloat. And that's one of the things that you got to recognize with parseFloat. If you're going to be doing strings, just remember that with the exception of scientific notation, that it will always interpret the string as is as soon as it hits an invalid character or at the very end, it will stop and return you that number. And that's how parseFloat works with different data types. And that's all there is for parseFloat. I hope you enjoyed our video. Hope I didn't bore you to death. Please view all of our videos at www.boringjavascript.com. Subscribe to our YouTube channel or check out everything we have at www.thevirtualoid.com. Thanks again for watching, and we'll see you later.